Hi, I'm Jenny. I'm a staff engineer at our compute team here at DigitalOcean, which basically means I work on all things related to managing our virtual machines. I'm here to introduce the topic of DO's recent journey enhancing our droplet backups and how that led us to introducing incremental backups, which my colleague Xavier will go into more detail about later. Let's start by talking about how everything used to work. When backups were first introduced, it really hasn't changed much since then until recently. We had just a little checkbox that you could click when you're creating your droplet, and it would take a backup once a week in some 23-hour window on some random day. It wasn't something configurable. It wasn't something that the customer could say, hey, I want my backup during this time and this frequency. It was just something you could go see and say, okay, cool, I've got a backup every week. The other thing that it also had was if your droplet was destroyed, your backups would go away with it. Because your backups were considered part of your droplet and associated with your droplet. And the frequency was definitely not editable. So you end up in this screen where you've got like, here's when my backup was taken. You get 4 backups. And then when the 5th one's taken, the earliest one gets deleted. That's where we were. Now we've got kind of 2 things. First, we wanted to kind of quickly address some of the visibility to the customer, right? So we actually switched from a 23-hour window to a 4-hour window, which at least gives you a little bit smaller space to say, okay, this is when my backup will start. And the windows are just for the backup starting, not necessarily completing, because that can vary a lot based on the size of the disk, how much data has changed, and all that kind of stuff, and just network bandwidth and other things on our infrastructure. Then we also, which I think was a huge win, changed it so that when your backup is taken, you would just get, here's the day it will get deleted. So for our weekly backups, we keep them for 4 weeks. So in the UI now, if you go in there, you can see the date that your backup will be deleted. And it does not matter anymore if you destroy your droplet. If you destroy your droplet, you'll still have that backup there until the date it says it's going to get destroyed. And if you want to keep it around, you just convert it to a snapshot. So that was another quick win kind of thing that we just wanted to get some of that stuff out first. Then we got into the bigger things, right? We wanted to make them faster. And we wanted to make it possible to configure when the backup happens and how often it happens. So we've been rolling out to all the DCs one at a time a new feature to be able to select either weekly or daily backups and to be able to pick which time window your backup happens in. So if you pick weekly, you can pick the day and the 4-hour window. If you pick daily, you can just pick the 4-hour window every day that it happens. And we also did a bunch of upgrading and things, which I'll get into later, as well as Xavier will, that made a full backup when you copy all the data from the disk of your droplet, 60 to 80% faster on average. And obviously that varies based on exact use case and differences between what you've got on your machines. But and less than 30 seconds when we do incrementals and you haven't changed a lot of data on your disk. This is a huge win because when we did full backups, we were copying all the data every time, and it didn't matter if you'd had your VM powered off for days and weeks, right? And none of the data had changed. We were just copying the same data over and over again, which was sort of pointless in the end. But you always want to be safe and get all the data. So that's always the safest, you want to make sure you're doing it every time as much as possible. But and some of the changes we made also allow us stronger durability guarantees. So what were that second part when I talked about these are the bigger things, the challenges we had. So let's pretend we have, let's say 300,000 droplets and they all have backups enabled. So they're getting a weekly backup, one every 7 days, right? We wanted to add the ability to pick daily backups. But when you go to daily, you're going 7 times as many backups. That means we're throwing 7 times as much data around our infrastructure. So that's a lot more load really quickly. That would be like if we kept only weekly backups, but instead of 300,000 droplets having them enabled, we had suddenly had 2.1 million of them enabled. So that's a big leap. And we wanted to make sure we weren't going to have any trouble doing that on our infrastructure. So some of the problems we had were like all of our backups tended to be clustered at the very beginning of the 23-hour window. So all the load was in one spot and not later at all. So it wasn't really spread out. The scheduling system had no way to kind of extend it to make it more aware of like, hey, this rack of servers is getting too busy. We need to, spread the load out or slow down here and spread it out more. We also had I kind of mentioned this before actually, every backup was doing a full copy of every single block on the disk. It didn't matter if it hadn't changed, didn't matter if it was not necessary. But so that's a lot of data to be throwing around on our infrastructure and our network, not to mention storing on our storage. And then the last one is it was kind of challenging to replace an entire system, particularly the scheduling system, without making sure that we had a way to observe that it was doing what it should do and not have that broken by changes we were making. So we really needed a separate way to observe the system and make sure every single customer was getting the backups that they had asked for. So some of the things we've done. So we spread out. So I mentioned earlier, we went from a 23-hour window to a 4-hour window. That was a nice, quick way both for our customers to be able to see a more precise time when their backup would start, but also it allowed us to really quickly and easily spread the load out a bit across the days. So you can kind of see from this diagram that, there was a whole lot of backups happening. Now there's much fewer happening spread across 4 windows. That gives us a lot of room to be able to do more of them. And we also have been working on a new flexible scheduling system. This should allow us to be able to plug in more logic that says, oh, this particular thing, like the networking here is getting busy, let's slow down, or similar things like that to distribute the load evenly. We also enhanced our networking capabilities. So bigger, faster pipes, always good. Move more data, very useful. And these last two are the things that my colleague Xavier is going to get into more, which is we installed new block-aware storage infrastructure, and we built support for incremental backups, where you're only copying the data that has changed since your last backup. So with that, I'm going to hand it over to Xavier.
Okay, thanks a lot, Jenny. Hi, I'm Xavier. My pronouns are he and him, and I'm a senior engineer on the storage teams. So we are the teams that are in charge of the software and all the systems that back up spaces, images, block volumes, and all of that. And I would like to talk a bit more about the details of went behind the scenes to enable daily backups. It was not just a flip to switch. We had to do a lot of work, and a lot of teams were involved. So what you need to understand is that up until now, all the backups of droplet images were stored as large files. So those files were still sparse, which means that we removed all the zeros and we compressed them. But it still meant that if you wrote 100 gigabytes of data to a droplet, including the operating system, we would have to copy this 100 gigabytes to our servers every time you did a backup. So that means several things. It means that there's a lot of duplicate data that we store on all those systems, but it also means that we have to back up this operating system every single time. It meant that for a 100 gigabyte droplet would take over an hour and a half to back up every time. So if we want to do this at the scale of the entire DO infrastructure for all droplets, it doesn't work. So what we decided to do was to completely revisit the way we store images, droplet images more specifically, at DO. Instead of storing them as large files that represent the entire file system, we store them as individual blocks. Each block is stored individually, and we track them using metadata. This allows a lot of simplification. It allows us to remove the duplicate data, but most importantly, it allows us to do incremental backups, which means that when we back up a droplet, we only upload the blocks that have changed. The work of keeping track of which blocks have changed is up to the hypervisors, but we handled all the drivers that make it possible to upload all those blocks and to pull them back and rebuild the entire image from all those differential or incremental backups, to be more specific. So this applies mostly to backups, but it will also apply to the other kinds of droplet images. Note that when I talk about droplet images, this does not apply to volumes. That's a completely separate system. Here is an illustration of how this works in particular. In this illustration, The second backup does not have to back up the data that was uploaded as part of the first. And when it only uploads the data that was changed since the first backup. And when we restore from that second backup, the data is rebuilt using segments from the two previous backups that are combined together to restore the state of the droplet as it was on the second backup. This was a major challenge to implement because it was not just an improvement to our systems; it was a complete change of philosophy behind the scenes. We had to build new drivers for this to be possible, and of course, that also means implementing testing, making sure everything is reliable, making sure that everything works the way we are, that we're never going to accidentally delete data, and we had to also maintain a lot of compatibility with existing features, make sure that transfer of images between regions still works, make sure that in base images, custom images, all of that also needs to still work as well. The result of this system was a massively improved performance of backups. So a backup, if incremental, if only 200 megabytes of data had changed, this backup would now take under a minute, where before it could have taken hours. And even the regular backups, where you still have to upload the full image, which we still do occasionally just in case, those are still 3 to 5 times faster depending on the region. So overall, this massive increase in backup speed is what enables is one of the things that enables daily backups. As we speak, the deployment of all this system is still in progress. The most recent regions to which this was enabled were Toronto 1 and SFO2, and there's still more to come. We expect all this to be deployed to all regions at some point in the future. It was a big effort. It was made possible by work by a lot of different teams. Of course, we had the storage teams, but also compute teams, as Jenny talked about earlier. But we also had work from infrastructure, operations, security, UI, and many other branches of the company. So we're really happy with the result, and we hope that you'll be able to enjoy faster backups for the upcoming future. Thank you.